All right. So, what is the expected value? What does it mean to have an expected value? So, the whole concept of the expected value is built on the fact that it's a mean, right? So, what does that mean? It's an average. So, the expected value can be replaced with the term mean. We write it as e capital X, so we have random variable x, and then we use the symbol mu for mean, and it's also the sum from I equals 1 all the way to n, given the observation multiplied by the probability of that observation, or that event, or whatever's happened, multiplied by the probability and adding it all up. So we know that e of x here is the expected value, and we know that mu is the mean. Xi, we can also call it the outcome, and the probability of Xi is the probability of the outcome. All right, so we have a certain example. Let's suppose a discrete random variable x has the following probability distribution table. What we're actually telling us is the probability that the event will take place is given in the form of a table. And we don't call it a table, we call it a distribution. So a discrete random variable x has the probability distribution where you're given some kind of table, x, and the probability of x. So if x is, let's say, 1, 2, and 3, and the probability is 12 out of 25, 2 is 6 out of 25, 3 is 4 out of 25, and x can also be 4, let's just say, and these values, remember, have to add up to 25, so that's 10 plus 12 is 22, which means this is going to be 3 out of 25, so that all of these add up to 1, 12 plus 6 is 18, 18, 22, 25, yeah. So therefore we know that the sum of the probability of x equal to each of those x's will equal 1. Right. Okay, so from this here, what we're going to do is move on to the idea of finding the expected value of it. Right? Okay. So the formula for the expected value says you take the observations. So all of these are xi's. This is x1, x2, x3, and x4. And because this is a summation, we know that you're going to put 1 in there, that's going to become 1, it's going to become 1. Then you're going to change it to 2. Then you're going to change it to 3. Then you're going to change it to 4. And what are we actually doing here? We're multiplying. So for each of these, we're going to multiply them and then sum it. So the expected value of x will be equal to 1 times 12 over 25 plus 2 times 6 over 25 plus 3 times 4 over 25 plus 4 times 3 over 25. Let me calculate that here. Distribution tables can change, and we can also replace each of these with actually a letter p and be given the expected value. In that case, we've got to work backwards and solve the equation for the unknown. All right, so expected value of x in this case would be 12 over 25 plus 18 over 12 over 25 again, plus 12 over 25 plus 12 over 25 times. That's 48 over 25. And that's the expected value for it. So what is 48 divided by 25? 1.92. So 1.92, which lies around there, would be the average that we're looking for in terms of x 1, 2. Because of the probability distribution, if they're equally distributed, we just take 4 divided by 4, which is equal to 1, right? That implies. So here we've given weights, and we've given emphasis to certain parts of the probability. The one with the highest probability has been given more emphasis than those with less probability as well. So 6 over 25 and 4 over 25 actually makes up 10 over 25 for 2 and 3. And we've got 12 over 25, the percentage of 1. The percentage of 4 means that the median would be at 1.92.